Example 17. Okay, now this one I need to go through a little bit more. Okay, now, thank you. Shall we? Let's read the question. Use the standard series to expand this up to and including the term in x cubed. And you deduce the Maclaurin series for this. Okay, now we'll do the one thing at a time. Use the series, standard series to expand ln 1 plus x. Now, let's look at this expression. Ln 1 plus x. Look at your notes while you look at your formula list. The moment the question asks for use standard series, you must use. Have attention. The question asks for use standard series, you must use the standard series. What do I mean by standard series? Formula list will be all this. So can we look carefully? You know you're going to make use of this. Those of us as students can go, yeah. This one, ln 1 plus x, but you know ln 1 plus sine x, right? Correct? But never mind, we keep an eye on this. You also can take a look at sine x, because the question has sine x. Got it? Yes? So, here, therefore, I'm going to pick out these two expansions from MM26. Let's keep an eye on these two. There must be a reason why, because the question has ln 1 plus sine x, right? So you've got to use sine x, you've got to use ln 1 plus sine x, right? Okay. Now, how to use that? Thank you. How to use? Do you have any idea? You know ln 1 plus x. Never mind, let's use this guy first. Let this be x. Correct? Yes? Then you will get a sine x minus sine x holding square over 2 plus sine x holding cube over 3 plus dot dot. Now I would like to emphasize the importance of writing the plus dot dot dot, because you know that it's a never-ending series, it's a power series. Don't stop there, because this cannot be equals to this only stop at 3 terms. This is a never-ending series. It's just that we stop at the third term. Some of us may ask, why do I stop at the third term and not the fourth term and not the second term? Because the question says so. The question asks up to x cubed. So no matter what, you start at x cubed, you won't go wrong. Follow? Yeah? Alright. Then how do we continue? The question asks us to use the standard series to expand this up to this x cubed. This is not good enough. I want a power series. I want a polynomial. I want x squared, x cubed. Can we take a look at this now? Sine x is x minus x cubed over 3 factorial. I substitute x sine x in. Which is x minus x cubed over 3 factorial. This one is actually sine x, because sine x is this. Sorry, I forgot the plus dot dot dot. I should be consistent. Cannot erase. Why cannot erase? Plus dot dot dot. Minus away x minus x cubed over 3 factorial. Plus, x minus x cubed over 3. Not 3 factorial, it's 3, sorry. 3 factorial, sorry. 3 factorial. Then you say, oh, so complicated. How do I do this? Never mind. I would like to explain, even though it's printed for you, I would like to explain, because how some of us may wonder, how do I jump from here to here? Look, have you finished copying? Once you finish copying, look outside, I know you're ready. Many of us will wonder, how do I get from here to here so fast? Actually, it's not that bad, because from here, from this first term, I'm only going to pick up this x minus x cubed over 6. Correct? This one. From this here, oh, there's a square. Sorry, I forgot the square. My bad. Sorry. There's a square here. No, actually, when you expand this term, this one out, you actually get 3 terms. Right? A plus b squared is a squared plus 2ab plus b squared. But I'm not interested in all the 3 terms. Why? Because if I can try and expand, the first term is a squared. That means only the x squared. Actually, I'm only interested in x squared. Because the question asks for expansion of the x cubed. The other terms, like x cubed to the power of 2, which is x6, I'm not interested. I'm not going to pick it up. I'm going to pick up the a squared term. Don't follow what I'm saying. Follow? So, this is from this one. This one also. This is, for those of us who want to write it out, we write out, okay? This one, you get x minus x cubed over 3 factorial, x minus x cubed over 3 factorial, x minus x cubed over 3 factorial. This is this, right? Cube is 1, this one times this one times this one, right? But because I'm only interested in the x cubed, I do not need to expand everything out, because the moment I expand out, wow, it will be a big mess. But I'm only interested in this times this times this, which will only give me the x cubed term. The other terms, x4, x5, x6, whatever, I don't care. I'm not interested, because I'm only interested to expand out the x cubed. So therefore, it's more simplified from here to here. Follow? All good? So the rest is just done. Okay. Next part. Deduce the Maclaurin series for ln 1 minus sin x. Okay. Many of us, as I go through tutorials in class, I realize that some of us actually don't quite follow instruction. The word is deduce. Okay, I'm going to erase some highlighting bits, okay, just to be clear. Okay. The key word here is deduce. Deduce means use this answer. Use this to deduce this. There are no marks. Thank you. There are no marks given here. But if there are marks given here, I do not think that it will be anything more than 2 or 3 marks. So you're not going to do all this all over again to find this, you know. You're going to make use of this result to deduce this. You know what I'm saying? The question is how. Right? The question is how. There's a trick here. Okay? The trick here goes like this. You have to, okay, I'm going to write a side note, have to make use of ln 1 plus sin x. Correct? You've got to make use of this. Now, you have to make this appear. You have to make this look like this form. Correct? But how? You have to be a little bit familiar with trigo, such that you are able to tell me that this is actually ln 1 plus sine negative x. This trick, if you know, very good. Why? Sine negative x is negative sine x, so these two definitely equivalent. Right? Now you know this, then you can now make use of this because this is this. Ln 1 plus sine x is this. Ln 1 plus sine A is change x to A. Ln 1 plus sine B, change x to B. Ln 1 plus sine negative x, you just change x to negative x. Got it? All got it? Just change this one, all the x to negative x, and we're done. So you refer to this, sorry, the x square is outside. Plus dot dot dot. Okay? Simplify, we can answer. Okay. Now I would like us to think this one. This is tricky, this is tricky. But can we spend a little bit of time, maybe like 1 minute to think how do we make use of this one to solve this one? Not easy, but I think some of us can do it. Very good. 1 minus sine square is right. Okay, I'll give you first step. Some of us can see immediately. Cosine square is 1 minus sine square. But not done yet. This one is still not of this form. Because we replace x with something, not replace sine x with something. I heard something? Very good. 1 minus sine x, 1 plus sine x. Very good. Factorize 1 plus 1. The next one, you factor 1 minus sine x, 1 plus sine x. Then, how? Can we continue? Or cannot? Remember, we're going to make use of this one, right? But you use your laws of logarithm. Laws of logarithm will tell you that ln A times B is ln A plus ln B. Correct? Yes? Ln A times B is ln A plus ln B. Why I cannot select this stupid rectangle? There. Got it? I think we're done. Why? This one is part 1. This one is the standard. Just take these two plus together, we're done. Yep. This is part 1. Right, this is part 1. Just copy and paste. Can you all copy? Yes? Can you all copy and paste? You all can do it. Well, I try and select this stupid rectangle. I cannot select one. Don't know why. Lazy to write. So I can move. Yeah. Done. Copy this. This one is from above. Done. Take answer. All good? I didn't realize I'm so fast. To think I actually can complete. Can complete this. I don't rush. I'll take a break. Relax, okay? Relax. Question, example 18. Wait, drink water first. Example 18.